Hello and welcome back to Calculus 3. We have exam review going for tomorrow's exam. Exam is on chapter 12. We are looking into 10 problems that will be on sections 12.1 through 12.9. And I said that most likely two problems will be from 12.7, right, to make 10, because we have 9 sections, where you have tangent plane, linearization, and differentials. We looked at some quick examples last time. The first example here was a question on how would we work on problems that have level curves, where I said, well, here's a function, find the level curve for z equals to 3. You plug in 3 for z, as you can see. This is the same square root 2x squared plus, I was just lazy to write it, from where you square both sides and you actually come up with the equation of the ellipse. So the level curve is an ellipse when you cut this shape with the xy, well, with the plane parallel to the xy plane, which is equals to 3. The next question was, oh yeah, that beautiful question on the limit, which actually originally had the minus in denominator, and the answer was quickly 0. But then we decided to change that into a plus and then go crazy trying to figure out the solution, because no matter what we tried, we always got 2/3, which might be the actual limit of the problem. It's 2/3. So 10 problems. If we have a considerable amount of spicier questions, right, we will have a replacement question. The min-max question and Lagrange questions are those that are, right, the carpal tunnel questions that take forever to solve. So you should leave those last. Stuff that goes very quickly would be the chain rule. I know many of you are really liking the chain rule. You draw the tree, get the equation for. Directional derivative is a quick stuff. Find the partial derivative, find the gradient. So there's a lot of quick stuff. Longer problems are the limit does not exist problem. Oh, also short problems. Find the domain, level curves, and match the shape to a picture, right, for the multiple choice. So one question or 2 questions, multiple choice. They're generally either 4 or 5 points each, and it's all or nothing. So no partial credit if you circle wrong one of the 4 options. If you circle 2 options at the same time, obviously the problem is void and you use all the points. So make sure you circle exactly one answer. If it's correct, it's +4 or +5. And if you circle it wrong or circle more than one option, it's 0 points. Yes?
Did you go through the shapes?
I did in 12.1, and I pointed out the book. Yes, I will. Yeah.
Okay.
So for the shapes, you just need to know the equation and the name. You should be able to connect those if you know the words, right? What is the hyperbola? What is the ellipse? What is a parabola? Then cutting those shapes, right? We used Rob's head as a watermelon. Oh wait, Jake, you were the horse, right? So for the saddle point and hyperbolic paraboloid. So we had those concepts should be clear because we had our models over here. And that leaves us with the long problems. Long problems are limit and min-max, and also the Lagrange. So those you guys should be working on at the end of the, right, so you finish everything else on the test, and then you go back to those problems.
Question.
Yes?
What did you say about another problem? Like you said something was too spicy. Like if it was too spicy?
I don't think there's a replacement problem.
Replacement problem.
But what is
It's on the
that?
first test.
No, because the first test was a joke. I mean, you guys said a 90 average. The replacement problem is, well, I picked that up from my physics professor like 20 years ago. He would give us 5 problems on the exam, and then the 6th problem would be a replacement problem that can replace any of the problems on the test. So let's say you can't remember for whatever reason, well, not for whatever reason, you actually studied all day on Wednesday, you didn't sleep the night you studied, then in the morning you reviewed, right, all the way up to class. So you've been working on all the concepts for the test for 24 hours without sleep and food and so on energy drinks. So obviously when you come in, you'll be brain dead and tired and everything else, and you won't be able to recall a formula for, let's say, directional derivative. So you replace that with a replacement problem. That's technically all it is. Or you can do what you did on the last test. You answer everything, your score is A, and you do the replacement problem just for fun. You don't need it, you just do it because you're awesome. Yes?
You do replace the problem, you have to say like what question.
Yes, you will say I'm replacing number 6, let's say, and I will not even consider number 6. I will just cross it out. Because if I have a replacement problem, the grading process is as follows. I check the last page first and see if the student replaced any problem, and if you replaced any of the problems, I go and I cross that problem without looking and I write replaced. So that problem might be right, might be wrong, right? You might take the problem that you did right and replace it, and you do the replacement wrong. That's, yes?
Do you think the replacement problem equally as hard as other problems, or is it like more hard because it's an extra credit?
Again, question to me. All of this stuff to me is a joke, so I really can't answer the weight of the, right? So let's say the replacement problem is another Lagrange, right? Let's say it's another Lagrange. So you have problem number 7. Let's say I didn't write the test. It's tomorrow, so I have time. So let's say problem number 7 is Lagrange, and then replacement problem is Lagrange. And you can't remember directional derivative formula, which is a dot product, right? So pyong, right? So you're replacing a problem that it's a simple dot product with a Lagrange. Or it could be the other way around, right? So that's something. It's decision making, right? It develops that skill. The only time when your replacement problem is ignored is when you write, instead of the number of the problem you're replacing, you write to replace whatever is wrong. Well, I then go and I replace something that is right. So, because you leave me the choice, and I'm not nice. So I see, oh, your problem number 1 is correct. Well, now it's replaced by your replacement problem. Oh, replacement problem is wrong. That's like 2 for 1. Perfect. Yeah, I see those smiles. Is he serious? Always. Good. Any questions on the problems? We did limit? Yes.
Can we do a Lagrange problem for like the closest point to the plane?
Yeah, please.
Lagrange problem, closest point to the plane. Now or at exam? That's.
No, please.
It was funny at the review for my Calculus 1, a student asked me, do we need to know the definition of the tangent line? I said, thank you, now I know what I forgot in the list. Write it down. It wasn't on the radar at all, but now it is. All right, so you want the minimum distance to a plane. That's problem 30. It's in the book, right?
Yeah,
No, it's just 12.9, right? Minimum distance to a plane. Find the point on the plane. So we are looking for x, y, z. On the plane, 2x plus 3y plus 6z minus 10 equal to 0. Closest to negative 2, 5, 1. Great. Well, I definitely have one equation. What would the other equation be?
You said to know what the distance was.
There we go. What's the distance formula now?
Oh, square root of x squared divided by. It's been a while. That's been point.
Minus x squared plus y 1 minus y.
Yes.
There you go. See, honors college.
Okay.
No, I got that wrong.
Well,
Oh,
you tried.
Great. Distance formula is just a Euclidean distance, and that's a square root of all these differences. What happened?
No,
Oh, I just.
that's my bottom. I thought was in honors.
Oh. Opportunity missed, right? So now, I do have a point 251, so that gets plugged in here. So I have, now, objective is to minimize distance. Therefore, this is my fxy, z, right? It's a square root of x plus 2 squared plus y minus 5 squared plus z minus 1 squared. So this is my square root over here. And we have our g, x, y, z, which is the constraint, right? It has to be on the plane. The point has to be on the plane 2x plus 3y plus 6z minus 10. So we had to do some work to come up with equations. The rest is a grind. We have to find the gradients, right, with partial derivatives, and then we have to solve. We're going to have 4 variables here, x, y, z, and lambda. And we'll try to kill lambda off because we don't need that one. And whatever x, y, z we get from the calculation is the x, y, z we're looking for. So this is great. I have the del f. So the derivative of this is going to be, so what is the derivative of square root of x? It's 1 over 2 root x, right? So what is the derivative of square root of f of x? It's going to be f prime over 2 square root of f of x. So if you know these this square root, I'm not writing the whole thing under the square root. That's just, so here I'm going to take the blue star over here and I put the blue star over here. All right, there you go, done. And then 2 times z minus 1 for the partial derivative in respect to z divided by 2 times the square root of the blue star. So whatever was under the square root before is still under the square root. Now all of these 2's are going to die. There we go. Now we have a del g. Now that's 236. Nice. So what do I have? I have my equations as x plus 2 divided by the square root is equal to 2 lambda. Y minus 5 divided by the square root of the whole mess is equal to 6 lambda. No, 3 lambda. And finally, z minus 1 divided by the square root is equal to 6 lambda. And I have 2x plus 3y plus 6z. You can put equal to 10. Whatever. Is that the same? 2x plus 3y plus 6z. Good. So now what we got is the system of equations that we want to solve. Well, this is what we are going to do.
You said the lambda equal to each other. Can we get rid of
Yes. Yes. You are going to calculate each lambda. So you are going to move 2 in the denominator on the left, 3 and 6, and have lambda equal lambda equal lambda equal. And then you are going to equal the first two, and let's say first and a third, or second and a third. So you are going to eliminate lambda. So from this equation, lambda is x plus 2 divided by 2 square root. From this equation, lambda is y minus 5 over 3 square roots. And over here, lambda is z minus 1 over 6 square roots. No, numbers. So now we are going to equal, let's say, first and a second, and first and a third. It doesn't matter. You can do second and a third, whatever. So what do I get? I get that the x plus 2 over 2 times the square root is equal to y minus 5 over 3 times the square root. As you multiply the whole equation times the square root dies, and what you're left with is 3 times x plus 2 is equal to 2 times y minus 5. Then we equal the first and the last, so x plus 2 over 2 square root is equal to z minus 1 over 6 square root. Again, times the square root, and we get the equation 6x plus 2 is equal to something.
The big one from before.
This one. And I really don't want to write it. That's the roots. That it's every single root that I'm writing has all of this stuff underneath. And yeah, I'm not writing it. So 6 times 2 z minus 1. Yes.
From the first one, x plus 2 over 2.
I moved the 2 on the other side. Yeah, cross multiply, yeah. All right, so what do we have? Now, we have 3x plus 6 is equal to 2y minus 10, which gives me the equation 3x minus 2y is equal to negative 16. The second row is 6x plus 12 is equal to 2z minus 2. So that's going to be 6x minus 2z is equal to negative 14. Yeah, because it cancels, right? It will. And now I have a third equation, which is 2x plus 3y plus 6z is equal to 10. So this is the system that I can actually solve. What should we kill? We can, well, the easiest to kill would be z, right? So times 3 to kill z. So copy the first equation, 3x minus 2y is equal to negative 16. And now add equations 2 and 3. I multiply equation 2 by 3 to get negative 6z, and that cancels with 6z on the bottom. So 1820x plus 3y, z's are dying, and then we have negative 42, negative 32. right? That's a negative 42, and then 10 minus 10. Good. All right. So now we have this thing to solve. Multiply the top equation by 3, bottom equation by 2. That will kill y's. What's 6 times 3? Plus 2. 18 plus 2 is 20. Because I want to kill these. Solve them any way you want. This is now, pre-calc 1. This is 5 courses ago. So whatever magic you can master to solve this is fine. All right, so the top one is 9x minus 6y equals to negative 48. Bottom equation is 40x plus 6y is equal to negative 64. When I add these two equations, I'm getting 49x, y's are dying, and we have negative 112. At this point, I would say something went wrong somewhere because the numbers are working the way they are, but right, such is life. We have x to be negative 112 over 49. I don't like this answer at all, but cancels 16 over, yeah, 16 over, negative 16 over 7.
Yeah.
But still, yeah, bad. So now you take negative 16 over 7 and plug it back up there to get y. Then you pick those up and bring them into G equation to come up with Z. So I have 3 times negative 16 over 7 minus 2y is equal to negative 16. And that is going to calculate. So what I have negative 48 over 7. No, I moved that to the other. Minus 2y is equal to negative 16. And I'll just put the, there we go. I'll just do it. Get x, y, z. Next problem. That's actually a project. Calculus 1 project or Calculus 2 project, depending on where we land with our area between two curves. It's 6.2, so it's the part of both classes. Find the area of this shape.
Oh.
So what do? Yeah. You fit whatever functions fit that, and then you have the top function minus the bottom function is the integral, and there you go. There you go. It's a Calc 2 project. There are projects everywhere you look. You know what another Calc 3 project is? See that fan over there? How much air is it pushing forward?
A lot of air.
Yeah, I want to know exactly.
By particles or by what?
So what do you have? You have the dimensions of the fan, and then you have something that's called flux, and then you have to go, yeah, there's something that's called flux, and something that's called vector field. It's chapter 14, coming up. That's just how much stuff is coming out of the surface, that's flux. Yes, that's one of the applications. But the stream of then fields are also bad.
What should this? It's similar to it, nothing to do with it.
That's what you think now. Give it some time. Any other problems? So, right, you good with this? You'll be able to find all your fractions? Anyone else? Also, check all of my calculations prior to this because
You only have enough to check the
12.2?
Yeah, that's all you have for it.
Uh-oh. All right, I better do that. Are there any other questions for the review? Because I want to shut it off. Yes?
There's like a certain amount, certain kinds of questions that you can get from 12.1. There's like intersection questions, and there's like three-plane. Like,
Yeah, they're cool questions, yes.
what are, you just like list them out?
Well, yeah, intersection of the plane and a line, intersection with two planes, and then all the shapes, equation of the plane, and how to get it, right?
Will there be two questions from that chapter then? Because, like,
From that section. So you really want to have more than 10 questions, I see.
no, but like you said, it was 12.7, so then there's no.
I said most likely. But then I can revert and have 2 from 12.1. Right? I'm just to 12 questions. That's the way you have it.
I don't want to buy one. Okay.
Yes.
No, that was
That was a good question. Okay. I just need to post the notes. Any other question regarding the graph? So you're all good with trees. You're definitely having a tree question.
Oh, we have to like make a tree.
Yeah, make the tree and then, no, not pick the tree out of 4, make the tree. And then write the formula. Yes? Go. It has to be one of them. We'll see which one is the one. Yeah, luckily you don't hand in anything, so you're safe. See, they're first, right? Clear goals. All right, so that's it for the review then. For the moment, I thought she was going to ask a question.